Have you ever wondered what the surface area of a human eyeball is? Or how much empty space is left in a box when you stick a ball in it? If you answered yes to either of these questions, man, have I got a video for you.
So first of all, the formula for the surface area of a sphere looks like this. The surface area is 4 times pi multiplied by the radius squared. The distance from the center of the sphere to any of the sides of the sphere. So the radius would be any of those measurements, and they should all be the same. Formula for the volume of a sphere is a little bit uglier. There's a fraction involved, which I know is going to scare a few of you. We still have our pi constant, and we're multiplying by the radius cubed. Same radius of that circular inside the solid. So this question says, calculate the surface area of a human eyeball with a diameter of 2.5 centimeters. I don't want to know how they determine that a human eyeball has a diameter of 2.5 centimeters, but the question's telling us that's what it is, so we'll work with it. We have a sphere, we have a diameter of 2.5 centimeters. So remember, the diameter is the entire length from one side of the circle to the other. Remember, we want the radius, which is going to be half of that diameter. So in order to get the radius, we need to divide this value by 2, and then we're going to substitute that in for r. And that's really all there is to this one. And from here, it's just a simple application of your bedmass rule. Remember, brackets and exponents first. You're going to type in 1.25 squared in your calculator. Then you're going to multiply that by pi times 4. And remember, on your calculator, you might not have a pi button. So if you don't, you're going to use 3.14. But that's the approximate surface area of the human eyeball. Gross. All right, the volume of a sphere. This is kind of a difficult-ish example. We're being told that a spherical gemstone, so that's a spherical shape, just fits inside a plastic cubic box. Here's a nice diagram for you. And the edges of that box are 10 centimeters in length. We're being asked to calculate the volume of the gemstone, so that's the sphere, and determine how much empty space there is in the box. You can kind of picture this. There's some corners here that aren't being touched. We want to determine the volume of that empty space. So how much empty space is there in this box? So first thing we're going to do is apply our volume of the sphere formula. We're being given the fact this thing fits snugly inside this box. So we know that the diameter of the circle in the center of our sphere is going to be 10 centimeters. And we're really only interested in half of that. We need the radius of this thing. So we're going to divide our diameter by 2. So if we divide 10 by 2, we're going to get 5 for r that we sub into our formula. So we're going to plug in 5 into our formula, and we're going to cube that. What our formula tells us to do is multiply by pi, and then you're also going to have to multiply by a fraction. You're going to end up with 523.60 centimeters. Okay, so that's going to be the volume of our spherical gemstone. What we need to do is figure out how much empty space there is in this box. So if you think about this logically, I've got this box. This gemstone is taking up 523.6 centimeters cubed of the volume. To get what's left, what I need is the volume of this box. And if I take the volume of the box, subtract out the volume of my sphere, I should have what's left over, which will be the empty space. What we need first is the volume of our cube. You can calculate the volume of the cube by taking the length, multiplying by the width, and then multiplying by the height. In this case, all 3 of these are going to be the same measurement of 10 centimeters because it's a cube. So all 3 sides will be the same. So that's just 10 cubed, which is 1,000 centimeters cubed. So that gives us the volume of our box. We have the volume of our sphere. All that we have to do to determine the amount of empty space is just subtract the volume of the sphere from the cube. And when I do that, I end up with 476.4 centimeters cubed. So that's what's left over in this box. And that solves our problem.
If this video helped in any way, feel free to like and subscribe for more mathematical chaos. As usual, thanks for watching.